Good afternoon, everyone. Welcome to our last session today of the PENC Virtual Raleigh Seminar. We appreciate you all being with us today. We've got a great group of presenters today from McAdams, who is actually one of our sponsors of the seminar. So thank you to McAdams for sponsoring and for being here. We have three presenters this afternoon: Rebecca Stubbs, Graham Bruns, and Iona Thomas. Rebecca Stubbs, PE, has over 5 years of experience and serves as project manager in the Water Resources Department at McAdams. Rebecca's focus is stream stabilization and restoration projects with past experience in urban stormwater management design and master planning. She has various design and project management experience in restoration, stabilization, and mitigation projects, working with clients to protect their infrastructure investments and enhancing the natural features of their projects. Through this project experience, she has served a variety of municipal clients, mitigation bankers, and nonprofit organizations, and understands that each client has a unique project goals and is dedicated to ensure those goals are met, if not exceeded. Graham Bruns, PE, is a Greenway manager within the public sector at McAdams. He is passionate about creating transportation options for people of all ages and abilities, and strives to create balanced and equitable thoroughfares that are safe, cost-effective, and enjoyable to use. His skills related to designing bicycle and pedestrian infrastructure include developing cost estimates from planning stages to final design, bridge siting analysis, greenway plan and profile design, signing, striping, recognizing dangerous bicycle, pedestrian, automobile interactions, and application of AASHTO and NACTO design guidelines. Iona Thomas, AICP, is a certified planner who combines her passion for greenways with extensive technical expertise and management skills to design trails throughout the Southeast. She's a passionate supporter of greenways and believes they play an important role in economic development, creating healthy communities, providing alternate modes of transportation, and connecting people with nature. Iona is a national leader in greenways, serving on the East Coast Greenway Board of Trustees, co-chair of the biennial Southeast Greenway Summit, and an active member of the NCDOT Bicycle and Pedestrian Policy Committee. Thank you all for being with us today.
Thanks, Katie. All right, we'll jump in. We're so happy to be here today with PENC. This is a very important organization to us here in North Carolina, and we appreciate all of the content and education and advocacy that you bring to the engineering profession. So a heartfelt thanks from McAdams. So today we're talking about Streamside trails, and Katie did a wonderful introduction, so we're not going to go through this again. So this is us, and we're very happy to be here. So we're going to start off with a little orientation of talking about riparian dynamics. Rebecca, if you can just kind of walk us through here, so we're all using common language today and everybody understands the terms that we're talking about when we talk today.
Sure, thanks, Iona. Again, thank you, everybody. We're excited to be here. And so today, since we are talking primarily about streamside trails and considerations that go along with that through the design process, we want to start with establishing, like Iona said, common terminology as it relates to the riparian corridor. So since we will be working within that riparian corridor, we want to, acknowledge and state that the center of the riparian corridor is that stream channel itself. That'll be defined by channel banks, which then outside of that, it goes into a flatter, oftentimes wider floodplain area that gets inundated and accessed during storm events that occur usually 1 to 2 times a year. And so we expect inundation of that wider area in a semi-frequent manner. Outside of the floodplain, typically we will start seeing slopes increase, and so we refer to that as upland areas. So starting with the stream channel and working out is a lot of the various zones that we will be talking through today, and different pros and cons with each of those zones. Another feature that is often present in riparian corridors is sanitary sewers. So they are a gravity utility, therefore they often follow stream channels in a lot of situations, and in a lot of cases as water also flows downhill. So typically these are going to be located within your floodplain areas, as I mentioned, outside of your channel banks. And so from there, I'll hand it back over to Iona to talk about how trails fit into this picture.
Thanks, Rebecca. So as we're going and tackling our trail projects, we work along a lot of stream corridors. So I'd ask you to think about all your favorite trails. A lot of them will have the word creek in it, the word river in it, Neuse River Greenway, Tanyard Branch Greenway, Branch Creek Stream. And the reason that we are in stream corridors is that when we get, and you all know this, as we get into the upland areas, there's a lot more competition for that land. It is developable, valuable land, especially in some of the urban corridors, but throughout, that highland, upland area. Ideally, if we are locating a trail along a stream, it should really be up in that upland area, so that we are up and high and dry, and that there's a long distance for the natural vegetation that occurs between that upland area and our stream bank to filter and treat the water and slow the water down as it comes down the hill. Now, that's in an ideal scenario. So that green area that you see is kind of our ideal. But given the amount of competition for that land and how expensive it is and how traditionally underfunded or poorly funded greenways are, we end up down here closer to the stream where it becomes more problematic. And we're going to go through some of the pros and cons with each of these areas. So when we're looking at this high and dry area, obviously we're going to have lower maintenance costs because this location is not going to be inundated by stream flooding. And we do have fewer and water quality impacts, and it's going to be a much more easy permitting path. Some of the challenges we talked about are the high property cost and the competition for that land. We do encounter more tree clearing, and when we try to minimize that tree clearing, we can incur some more costs on the project when we're using retaining walls or structures to try to keep our clearing impacts as narrow as possible. When we look at this area, and we'll just call it floodplain fringe, this is a very common area for us to be in. And we have, again, lower property costs because traditionally this is not going to be developable land. And there may be areas that are under existing easements or public control. It's getting flatter, so the design to get comfortable grades in there and the amount of clearing we would have to do is less. And then we know that people like to be close to water. So this is getting people down and close to the stream. Some of the challenges is that we do have more impacts from water quality and quantity point of view because we have a shorter distance between the edge of this trail and the stream bank. We would require floodplain modeling and permitting anytime we are inside of the floodplain. And then this is going to be a more flood prone area and is going to see higher maintenance costs because of that. When we get into this Streamside area, and this is what we're going to be talking today. So we preface this by saying you should ideally avoid being here, but a lot of trails end up here because this is the land that is available, and it is a corridor that is already under public control. So it does often overlap with an existing sewer line, and that makes it a little easier for us to get in there for construction access. And it's usually already cleared and maintained, so we have a low kind of clearing impact, and it's very close to the water, so people really like that. Some of the challenges is that this is a very flood prone section of the riparian corridor. We do have more water quality impacts. This certainly requires FEMA modeling and permitting. It's also going to require stream buffer permitting for most jurisdictions and in certain basins in North Carolina. And then the relationship of your trail to your sewer is can be problematic as well. Obviously, we can't drive piles on top of sewer lines, so we often encounter jurisdictional wetlands behind this natural kind of rim that goes into the stream bank. And we usually cross those with boardwalks. That becomes more challenging if we're on a sewer. And then the sewer maintenance has to be, the access for maintenance has to be maintained. And we all know what sewers smell like. So that is an issue as well. So when Streamside is our only choice, we're going to take a look, we're going to switch over to a little video and show you what this looks like. So we're going to look at two different trails and come back and get into the conversation a little bit more.
Happy to be with you here today. Today we're going to talk about Streamside trails, and this is Boiling Creek, which is a creek stream that runs through Chapel Hill and Carborough. And we're looking at it today because there are sections of very popular trails, some of which are paved and some of which are not. So it's a good opportunity for us to look at
I think the video stopped there, Iona.
what those choices do to our streams. So this is the unpaved section in Carborough. You can see that it is all different kinds of activities and a lot of volume. You have people who are making their own way, and that makes the trail wider and wider. As a mud puddle comes along, people make their own path. And so you can see here we had someone on the right, now we have someone on the left, and the trail just gets wider and wider. It's about a 20 or 30 foot wide trail as it meanders here along the creek, very close to the creek. So here we're going to talk with Rebecca Stubbs and Graham Bruns. So Rebecca, I'm interested in, as a stream restoration professional and water resources expert, when you see this trail, what do you see?
So what I tend to look for is, where are the low spots, where is water? You always want to think about where water is coming from as it crosses the trail. Often trails are set up so that you're walking along the topography that it's that is along. Sorry, he's friendly.
Graham?
Trails a lot of times are running alongside and along a similar contour, fairly gentle, intentionally so. And so that can often make it more challenging for stormwater to either flow across or ends up flowing along. And so just generally speaking in trails, regardless of surface, you do want to be mindful of what those flow patterns are in local situations. So when they come next to streams, the biggest thing from a stream perspective that we want to look at is, where are those concentrated points that water eventually goes over the bank and into the channel. But lots of water anywhere can be very destructive. So being very mindful of where it enters the channel and making sure that it's not ever too much at one time.
And then ideally, when we're looking at a scenario like this where we have water coming down a steep hill, we be looking for a buffer of some kind of vegetated buffer?
So yes, vegetated buffers are one of nature's best ways to stabilize surfaces, to hold soil in place, but then also can provide some of that roughness that also slows down water. So it naturally provides speed bump of sorts. as water transitions from a smoother surface or a bare soil surface into a vegetated buffer. So buffers are another, very important piece of this. If there are ways to, keep water in a sheet flow form through vegetation, that's definitely the most ideal situation.
Mm-hmm. And then when we look at a trail like this that has a lot of kind of raw earth, what does that do to the stream when the water comes down the hill and across a rock?
Iona, it sounds like the audio cut out.
So since, we can see areas where there isn't much vegetation along the trail, it receives a lot of concentrated water. Wants to take that soil away with it. So that ultimately ends up to be a contributing source of sediment within your stream channel, in addition to whatever may come off the banks whenever it enters.
And then we hear about the word turbidity in streams, and that turbidity is a bad thing.
Yeah. So turbidity can be very detrimental to a lot of in-channel habitat and in-channel macroinvertebrates, which are a lot of what are good water quality indicators. And so as soon as we get more sediment in there, there's not as much light, which they need to either grow the vegetation that they feed upon or just for them to sustain life. And so generally speaking, the clearer the water, the better quality it is. But yeah, sediment is definitely a detriment to that.
So is there a link between a raw earth trail right next to a stream like this and turbidity?
Yeah, I think there could be. If you've got, especially in this situation where you do have a pretty steep hill on the away from the stream side of the trail, then on the upland side of the trail, that can promote a lot faster runoff. So stormwater runoff running across this bare earth trail into the channel would be, conditions are ripe for sediment to enter the stream channel. So right here is the spot you can kind of see the bank is coming straight and then it dips out towards the trail here. There's no real vegetation. There's some, grass and moss present, but a lot of this is likely due to drainage that's coming down from this hill right here, and then it's just entering this channel right at this point. We're kind of looking at localized grades. It does look like this is a little bit of a sag in the trail as well, so you can sort of see what that lowland concentrated flow entering the channel could do here. And so this is something where the vegetation is gone because it's probably been washed away repeatedly over time. So this is what you want to watch out for.
So this is still Boiling Creek, but now we're on the paved section of Chapel Hills Greenway. And Graham and I actually designed, this is one of several sections, and we designed this section. You can see that it's very similar. We've got the sewer there on the left-hand side, very close proximity to the creek. We armored this downstream or this downhill side of the trail here to protect it and to let some vegetation grow up. And we're threading the needle. There's that giant rock there on your left-hand side. There's a lot of rock on this project. So some pretty tough constraints. So I'm going to invite you along to eavesdrop on the conversation that Rebecca and I were having as we were checking out the trail. Yeah. So here's our sewer. We're actually we're right on top of the sewer line with this project. This is a sealed manhole, which allows the utilities to come in here and get to it if they need it. But we don't have two separate utility and trail alignments that are taking up space in the buffer.
And since the utility maintenance will require heavier traffic loading that otherwise might be in a natural easement surface, providing a paved surface.
The video is
Rebecca, what do you think of this solution here where using
I'm just going to pause it for a second.
So I think use of the riprap around the edge to ensure that this bank will be stabilized. Really good use of rock here to ensure that this water is sheet flowing off of the smooth surface of the concrete. It's hitting rock prior to entering the channel. So this is what will help prevent some of the bank erosion as water is going over top of the bank into the stream. Awesome. Okay. So here's another spot where we've got a low point sag in the trail. You can see where water is concentrated here and is entering the channel where we've just showed. This is a similar spot that was pointed out on the natural surface trail previously. And so you can see water acts in a similar manner, but here we've got a better stand of vegetation. You know, where I'm standing right now, not as thick as, you know, we would like, but as it's going into the channel, we do see a lot more vegetation there that's holding that soil in place, and then some rock down below that's protecting that bank. So this is your concentrated entry points into the channel are always what you want to be mindful of, and make sure that you're, you know, seeding those, planting them, just making sure that they stay with the best. The most erosion is going to happen as water comes off of the new trail and into the stream. So the section that we're looking at here is a good example of, you know, trying to keep as much of that riparian area as you can. So as much vegetation, hardwoods are good. They've got deep roots that'll hold and anchor that bank together. And then the shorter ground cover is also an important part, and that's where you're going to get most of your, you know, nutrient uptake, sediment fallout is going to be through the grass and the herbaceous plants there. But maintaining, you know, as much buffer between the edge of your trail and the stream bank is critical and important, and that's, you know, kind of the ideal situation.
Let's talk about how we achieve that vegetation right up to the edge of the trail that Rebecca was talking about. And we do that by creating very stable shoulders for our trail and seeding back all the way to that. We're going to take a look at a couple of examples on this trail. There are a couple of different segments, and one has really good stone shoulders on it and stable vegetation. And we're going to take a look at another one that doesn't have that same.
We also want to talk about the shoulder here. So this shoulder is actually a constructed shoulder.
Oh, okay.
So this is 2 feet of stone, and then you see back up to the edge of it. So you're immediately getting vegetation right up. This itself, right? So shoulders are incredibly important. Yeah. You can see in the shoulder, we've got nice vegetation all along the edge here. So as soon as that water leaves the trail, it's being treated.
And the vegetation is helping slow down the runoff as well, so that it's not erosive. And you can see this is in good stand.
So this is the same trail, but this section of trail was designed without the 2-foot shoulder. So you can see here it was formed up, and then we just have bare earth here. In the section we showed you earlier, we have 2 feet of stone built up to the edge of the trail, and then we seed right up to it, so we get vegetation right to the edge of the trail. This is also problematic from a shoulder point of view, because on a bike it's easy to get off the steep curve, it's easy to roll your ankle. So make sure when you're designing either asphalt or concrete trails that you are including that 2-foot stone shoulder. It's going to help you both from water quality, safety, and protecting the life of the trail, especially with asphalt. It protects the edge of your trail, and you get a lot more life out of the trail.
So hopefully that's given you a little glimpse into some of the design challenges we're trying to balance when we're designing close to streams. If you can avoid being this close to a stream, you certainly should. And I think as a community, we need to be investing in projects so that we can afford to buy high and dry ground. But in a lot of cases, we're still dealing with corridors like this, where it is wet and there are challenges with it. So I think intuitively, sometimes we think that if you're going to be this close to a stream, that a natural surface is going to have better outcomes for water quality. What the reality, though, is that the way that water behaves when we have an unstable surface like bare earth, it really does make it very difficult for any type of vegetative buffer to take hold. The user
And it has stopped again.
on the trail are adding to that with the mechanical limit the impact that they have on the corridor, and it allows vegetation to come back up and start treating the water as soon as it crosses the paved surface. So we've given you a lot to think about today. You will probably never look at a trail shoulder the same way again, and hopefully that's a good thing. We're very happy to be with PENC here today. You are a very important organization to McAdams and to our state. So we thank you for all that you do for professional engineers. And if you're interested in working on projects like this, McAdams is hiring in both our Charlotte and Raleigh-Durham offices for stream professionals and civil engineers. So check us out. Have a great day. Thanks.
Sorry about the technical difficulties there. Hopefully that came through okay for you guys. We are going to go through this in some more detail. And if I can get these guys off my screen. All right, so you can see here the two different stream sections and trail sections that we were looking at. And we talked a little bit about how the trail users actually impact how these trails contribute to water quality. So you can see on the left-hand side there that this is a very undefined area. It's 25 to 30 feet wide. And what happens is as mud puddles and obstacles develop, people just make their way around it. And this is particularly true on high use type trails where you have cyclists and strollers and dog walkers, where you have a high volume of people. Trails like this tend to just get wider and wider and wider. When you look on the left-hand side, we have a confined and very defined area. This is only 10 feet wide. And all the kind of human interaction in the corridor is confined to that 10 feet. And so the water, as soon as it crosses, is getting treated, and it's not picking up all of that, the sediment as it goes across. So Rebecca, you want to walk us through how water behaves on these two different corridors?
Yes, so just as Diana was talking about how the end user often can dictate what that width and surface material is of natural surface trails. A lot of times that traffic and the high use, just as she discussed, both of foot and then mechanical, will prevent any type of vegetation from growing on the trail. And even such, typically those people or typically users will often avoid sometimes those vegetated areas, thinking that's not where the trail is supposed to be. So we tend to see this very widening or increasingly widening trail that inches closer and closer to that stream channel. So with trails that are placed near natural surface trails that are placed near stream channels that inch their way closer to the channel, that is only aggravated also by having water that begins uphill and moving across the trail and into the channel. And so that both of those issues, I think, can just continue to exacerbate and contribute sediment into the stream channel, which would be, that's that primary water quality factor that we are considering here today. If we look at the picture on the right where we have that paved surface, I think, humans are instinctively kind of trained to stay on the pavement. So with that being limited to that 10-foot width, or even, to that constructed shoulder, as we've talked about, the impacts relative to the stream channel itself, remain constant, and they're a lot shorter. And so, though it may be an impervious surface, that water will travel across quicker, perhaps, than a natural bare soil surface. It at least is not moving as far across an unstable surface, and then it immediately enters that vegetated riparian buffer, which now can be wider because we've been able to gain, that additional width away from the top of that channel bank. So the primary drainage pattern that these trails that follow streams experience is that cross slope drainage from upland areas across the trail and into the channel. So really minimizing the width and then making it a stable surface are the primary goals here for having something that's long-term sustainable.
Thanks, Rebecca. So we get into this question to pave or not to pave. So we're going to assume that the jurisdiction you're working with has decided to pave and run through some of the design considerations that you need to take into account. Obviously, anytime you are working in a FEMA studied stream, you need to make sure that you're doing your FEMA flood modeling. As many of you know, FEMA maintains our flood insurance maps. So anything that we do within a studied stream area that could potentially raise the water surface elevation on insured structures has to be studied. And then we need to make sure we're coordinating with FEMA for any modifications to that map. So this is an important piece of Greenway design. Greenway design and floodway modeling are a very iterative part of our practice, and making sure that those two different design elements are working with each other is kind of the only way to get projects like this on the ground. We talked about the sewer. You need to make sure that you are doing your sewer coordination very early in your process. And there's a series of questions here, and there are other questions, but these are just a few that you need to get straight with your sewer authority very early. So can a trail be put on top of the sewer line? So we saw on the Chapel Hill project that we went directly on top of the sewer and sealed that manhole. Are there plans for new sewer lines? Where would those go? Can we have structures within the easements? So some jurisdictions don't let you even have structures within their easement at all. That's important to know early on. If you can have structures, how far off do they need to be from existing or planned lines? What's the maintenance access? And then can you lower and seal manholes? So there are other questions, but those are if you get all of those answered early in your project, you'll be in good shape. You also need to know that streamside trails flood. And so your clients and the jurisdictions that you're working with need to understand that this is a reality, and it's becoming a more and more common reality that these projects flood. And so there's some design kind of mitigation factors that we can take to deal with this. Material selection is very important. What we're showing here is asphalt that has been blown out during flood conditions. You can see on this one slide, actually we've got a better slide coming up to show you how the shoulders play into this. But asphalt, when it gets undercut and the water starts flowing underneath the edge and underneath the asphalt basically just floats and breaks. And so asphalt is not an appropriate material in areas where you know you're going to see flooding. So when we're going under bridges and other areas where we know we're going to have regular inundation, always switch those sections out to concrete. And you can also do on the stream side edge of your concrete, you can do some turn downs that further protect your Greenway trail from erosion. So here you can see on the left-hand side, that section of trail did not have any type of constructed shoulder. And I'm not saying if we had a shoulder, it would have totally protected from this flood event that we're seeing here. But certainly we do know that if you protect the edge of your trail with a constructed shoulder, that's going to help the life of your trail and help you avoid that. And so you've got the stone shoulder option, which you see on the right-hand side there. And then more municipalities are going to concrete kind of a ribbon shoulder that really locks in the edge of that trail and protects it. You also do need to plan for maintenance. And so we know that these trails, when they get flooded, that they have siltation. And so it's important to plan for maintenance. And so let's talk about shoulders. I'm going to let Graham take over and talk about this a little bit.
Thanks, Iona. And so this is a typical section I think we had in the video that this is what we're trying to achieve with an asphalt trail. Like Iona said, when we are getting into those inundation situations where the trail is being flooded, we want to use concrete. So this would be a different looking typical section with a turn down on the stream side. So probably on the right side there where it's sheeting across, and we can design that with an 18-inch concrete depth on that side, just that side, to protect against the flooding events and water running alongside it. For when we don't have a trail on that close to the creek where it's not expected to be flooded all the time, asphalt is a more economical design and holds up fairly well, especially if designed correctly. So we have a 6-inch, or I guess this is an 8-inch ABC base with 2 inches of surface. And then you can see in both of those red circles there, we've got 2 feet of ABC that extend past where the edge of the pavement is. And that is the stone shoulder that we're talking about. So you trench down into the dirt so that you're not creating a dam effect. Thank you. So that's the picture on the left here. You actually cut down into it, the width of your ABC. So that for a 10-foot trail, that's another 2 foot on each side. So that's 14 foot total. And then you pave on top. So that's our paving operation on top of your compacted ABC. And then you come back after your paving operation and you add additional ABC as those shoulders. And that doesn't have to be compacted. That's a structure that the compaction is really for the pavement itself, but those shoulders do settle in and they do silt up a little bit with the first rains, and we actually recommend seeding those shoulders as well. So I think if you go to the next slide there, Iona, we'll have so here's our snake. We've got lots of wildlife on the trails because they're along these creeks, but you can see that shoulder there on the left is a seeded stone shoulder. So you can see the grass growing up in there. You can see some of the bigger pieces of ABC, and that will silt up, and that may also, depending on your rain event, may wash out your fines too, but that's okay as long as that grass is in there, because that's basically going to disappear, but it's going to be a very solid and strong shoulder for both if you are riding your bike and you slip off the trail, and just to protect the edge of asphalt like Iona was talking about earlier.
So we do have a couple of different options that I mentioned: the seeded stone shoulder, which Graham just spoke about, the concrete shoulder to really lock in your asphalt. That's probably the most hardcore, if you will, shoulder solution that you can go to. And then you will sometimes see an exposed stone shoulder. This is only really for a high and dry condition. We would never recommend this for a streamside option. And so just keep in mind that you really want to come back and stabilize your stone shoulder with seeding after that. So with that, we can answer any questions, Katie. And again, apologize for the technical difficulties with the video. We'll try to make that video available to you guys if anybody's interested in it.
Okay, we do have a couple of questions. What is the minimum maximum cross slope you provide on paved trails?
So we try to stay under 2% maximum. So we do want to have that positive drainage and that sheet flowing to make sure that the water doesn't sit on top of the pavement. But we're kind of, we max out at 2%, and that's an ADA issue there. And that's usually typically enough. In our for bicycle facilities, we can go higher if it's a separate bicycle facility, but most of the trails that we're designing, it's for both bicycles and pedestrians. So we keep them under 2%.
All right. Have soil bioengineering techniques such as live fastens been used for streamside shoulder stabilization?
That's you, Rebecca.
Yeah. Often. Yes, I mean, that would be one great technique. Another could be live stakes or other bank stabilization practices. We primarily were speaking about trail design today, but especially if these trails are already alongside degraded stream channels and there's opportunity to uplift either through bank stabilization or stream restoration in conjunction with trail design and construction. You know, if scope of project can't get that big, I think that's one of the best ways to incorporate trails and trails and streams together and really benefit that entire system. But yes, live fastings, brush mattresses, vegetated soil lifts, all of those are great bioengineering techniques that can be used in conjunction, especially if you are in the design process or through existing conditions have already identified some weak spots of those concentrated areas where bank erosion can be observed already or might occur as a result of trail construction. I would be proactive about implementing a lot of those types of practices.
I'll just add that several of the projects that we have worked on in the past have been collaborative stream restoration and greenway design. And so that is a real opportunity there to have an iterative process between the greenway design and the trail restoration. And so if municipalities have a stream like this that has some issues with it and is a good candidate, it's a great, if you're going to be in there, you might as well just be in there once, get it all done.
Yeah.
Okay, could you discuss pervious pavement options and whether that sort of surface might mitigate impacts to the creek itself?
Yeah, so pervious paving is not anything that we would recommend in a flood-prone area. You know, the whole idea about pervious paving is that it has voids in it so that the water can flow through it. So you really need to make sure that you are putting those kinds of treatments in the right conditions. So flood-prone conditions are not suitable for that, because what happens is the first flood that comes in, all the voids are filled up in your pervious surface, and then your surface is no longer pervious. So even in those, even if you bought the equipment to maintain the facility, which is quite expensive, kind of the vacuum equipment to try to maintain it, in a truly flood-prone area, it's doubtful whether you would get the function that you were trying to get out of that pervious surface. Also, we don't recommend any type of, we try to get as many kind of joints out of our travel surface from a safety point of view. So we're never looking at something that's got, you know, like pavers or anything like that that could create hazards for trail users. So those applications are great, but they have to be in the right condition to function the way they're designed to function. Rebecca, did you want to add anything to that?
Yeah, I'll just piggyback on that response. I think you know, having a stormwater background, pervious pavement or permeable pavement, concrete, etc., typically are looked upon favorably to promote that infiltration that impervious surface removes. But to exactly what Iona was saying, in a floodplain situation, that's where a lot of any sediment that is in the channel, a storm event comes through and then it has a chance to spread out on that floodplain. That's where you're going to see your most sediment deposition. So that would potentially be right on top of that trail. And then, as Iona mentioned and explained, is that would prevent or remove that intended function initially. And so it would increase maintenance costs for an increased cost of product. I would guess that Iona and Grammy back me up on that, but typically permeable pavement is going to be more expensive than your traditional asphalt or concrete options. So for long-term effectiveness, I don't know that I would recommend it from a stream perspective.
Yeah, it's a little bit more expensive up front, and the lifespan, the life cycle of the pavement itself is probably half if it's maintained. So it's kind of a double whammy.
Yeah.
All right, can you talk about what does maintenance look like for a close streamside path?
So usually you're going to be cleaning, after these flood events, you're going to be cleaning large debris off your trails. And then the next thing is the siltation. So it's kind of unavoidable on these streamside trails that we end up with small areas that create some ponding on the trail. We do our best to design around that, but we've got, you know, the best practices with Greenway design have come a long way. And so on some of your older trails that weren't as well designed, you know, we see more and more ponding. And so you got to wait for that water to either drain or evaporate. And then you have to deal with the residue, the silt that's left. That silt can be very, very slick and dangerous. And so you're removing your large debris, so that's your maintenance crews out there, but then you're either coming back and you're sweeping, or you're using a sweeper on a small maintenance vehicle to come through and sweep that siltation off. I think that's your main, you know, you also, your bigger events, you're gonna, you know, maybe have a tree down on a railing, or you've got, you know, big issues like maintenance, like pieces of asphalt being undercut and lifted and broken. That's kind of the more extreme end of your maintenance, where you're doing a pavement repair because of flooding.
What is ABC?
ABC is aggregate base course. So in the yeah, that's your stone base. A lot of roadways are, depending on the size of the roadway, you might have an asphalt base, which is exactly what it sounds like. It's a graded asphalt. ABC has no asphalt binder in it. It's a graded stone that you can work the same way as an asphalt base. So it's basically what you pave on top of.
It's stone.
It's stone.
What thickness of concrete do you use for concrete paved trails?
So Graham, you can just make sure you talk about the turn down on that.
Yeah, the thickness is not dissimilar to sidewalk thickness. That's probably the small or the thinnest we want to do is 4 inches. Typically we shoot for at least 5 and maybe 6 if we can, because a lot of the times the loads on the trail itself is going to be a pickup truck. So we have to kind of think about that during design. And then again, for the turn down, when we do have those real close streamside trails that, especially under underpasses and under bridges, We do have, a section that is at least 8 to 12 inches deep. That also protects that edge during those flood events from undercutting and washing away.
So basically, we've got the concrete, and then on the stream side, we turn it down and we go down, 12 to 18 inches with that concrete. And so it's got a little kind of mini retaining wall on the stream side to protect the edge of the trail. And then we usually come back and riprap on top up to that edge to further armor that edge.
Okay, how does proximity to the stream negatively affect usage?
It doesn't. People love trails. I mean, people love being close to the water. I think you saw in our video, there was like somebody out there in the stream building some kind of rock thing. I would encourage you guys, if you are interested in trail usage right now, ITRI, NC State's Institute for Research and Education, has some great information out there on the uptick in Greenway usage during COVID. Fascinating. We've like doubled and tripled Greenway usage during COVID. But humans love water. We love to hear water. We love to be near water. And so it's definitely, to have that water feature, if you will, is a bonus for our trails, as long as they're designed well and balanced off the impacts.
How do we factor in impervious surface when deciding what trail surface to use near a stream bank, specifically the lower Ellerby Creek in Durham?
Well, I'm not going to talk about that. I can't talk specifically about it, but I will say that that's what this whole discussion is about. Taking what we, this intuitive thing that we think, oh, a natural surface trail is going to be better for the stream. What we see in practice is that if you have a really popular trail, there are some trails that are like single track hiking trails along streams, and those are perfectly appropriate. And you really, if that is serving your community, you shouldn't mess with it. And that's not doing a lot of damage to your stream. But when we see these really popular trails that have a lot of usage, and an undefined bare earth trail that every time you get a rain event and you get a mud puddle, it gets wider and wider and wider, and it never has the opportunity to recover, and the water goes across that and goes straight into the stream. And that does have the potential to increase sedimentation and turbidity, and really inhibit what something like we're trying to do with the Ellerby watershed. We're trying to bring that up and save that urban stream. And so I know it's counterintuitive to think that a natural surface isn't going to be the best option there. But I would say that if you look at kind of how your trail is going to function, are you going to have a lot of users on it? Is it a maintained sewer corridor that you're going to have trucks driving on? That's the other thing. Now on a paved trail, you've got sewer trucks driving on asphalt or concrete instead of that bare earth, and again doing that mechanical erosion. So I would look functionally at how your trail is going to behave, how popular it is, and then try to go towards a surface that will control how humans behave in the corridor, and will control how quickly the water begins to be treated once it leaves the trail. And you do that by controlling how humans disturb the corridor and letting the vegetation come up right to the edge of the trail. And shoulders, shoulders, shoulders. Design and build good shoulders.
Are you familiar with a product called Pave? And is this considered too pervious for a flood-prone trail?
So I don't know Pave specifically. We have looked into different binders for these types of trails. And again, the location is the problem. So those binders, and so what we talk about with a binder is you've got your stone, your ABC or whatever stone you're going to use, and then Paved and other products like that use a binder to bind that all together like a big Rice Krispie treat, and then you compact it. Ideally, some of those have voids in them, and so they are still pervious. In a floodplain condition where you're gonna see water, that is gonna become silted up. And then I also don't know how those perform when you've got any kind of water velocity that's kind of working on that edge, getting underneath of it. So I would, I can't imagine that they're gonna behave better than asphalt. We've tried, we've tried to use some of those and check those out, but the performance and it just isn't in there. If you're high and dry, if you're on a rail trail that's got like 2% grade over 20 miles and it never gets wet, that could be great.
What is the most ideal width of the trail, balancing cost with what users want?
So that's a really great question. And I would say, we've got a couple of things going on. A lot of these trails use federal funding. So right now, North Carolina, as part of the STI bill, defunded any state investment in independent bike ped projects. So there is no state money available for greenways and trails, but we do have access to federal money, and the federal guidelines require the trails to be at least 10 feet wide. 10 to 12 feet is recommended. We see a lot of jurisdictions, due to the popularity of trails, going towards 12 feet as a minimum, and then designing 14-foot trails for some of their busiest corridors. What we do know is that in busy corridors, 10 feet isn't enough, that we end up with user conflicts. You can have the same severity of accidents between a cyclist and a pedestrian as you would between a car and a cyclist, because what you're dealing with is the speed differential. So one of the other discussions that we have with our municipal clients is, the width, and obviously wider is better, but we're also having conversations about, do we segregate bikers from walkers? Those conversations are individual to each of the different communities that are putting trail on the ground. But 10 foot is the bare minimum, 12 foot is becoming the standard, and we're moving in some communities towards that 14 feet.
All right, we've got time for one last quick question. With population growth around Durant Nature Park in North Raleigh, stream flows increase, causing erosion of the shoreline, which continues to encroach on the paved Greenway Trail. This will be a constant maintenance issue, and I welcome thoughts on solutions.
So McAdams is actually working on Raleigh's Greenway Master Plan update, and as part of that, we're looking at realigning different sections of the trail because of some of these maintenance issues and some of the trails being so old, and streams move. That's, the human hubris to think that, our land doesn't move. Our land moves, and it is moved by water. And so some of these trails are in places that are no longer appropriate. So the city of Raleigh does, and I don't want to speak for the city, but as part of the Greenway Master Plan, we certainly have seen that the city of Raleigh is looking at where they need to realign some of these sections. And I'm not exactly sure the section. I think I know the section you're talking about. But I would encourage you, if you haven't participated in the Raleigh Greenway Master Plan process, to there's some information about that on Raleigh's website and some contact information there. So that would be a really appropriate way to reach out and say, this is an important link to us, but it's no longer functioning. Is it in the city's plans to move that out? I will also add, and Katie, I know we're trying to wrap up, but as trail users in our communities, we see a lot of things that the municipality doesn't have enough eyes to see. So I think if we can build as trail users kind of a respectful and collaborative relationship with the towns that we live in to say, hey, you know, this issue's going on here or that issue's going on there, that can be a really good thing. Because as you guys know, municipal staffs are stretched really tight and poorly funded. And they just don't have the ability to monitor every inch of trail that is out there the way that they would really like to.
Okay, Iona, Graham, and Rebecca, thank you so much for your time today. Everyone on the call, you will be emailed your PDH form, and I'll include the link to that video so that everyone can watch it on their own time as well. Thank you all again. Have a great evening.
Thanks for having us.
Thanks, everyone.
Thank you, Katie.